Welcome to Part 6 of the Heathkit AP1800 preamplifier series. In Parts 1 through 5, I told you about the history of Heathkit's Pro Series components. We unboxed the 40-year-old new old stock kit, built the circuit boards, removed the corrosion, painted the chassis parts, and completed the build. If you missed those episodes, you may want to go back and check them out. As promised, in this final episode of the series, we'll test all the preamp's functions, test its frequency response, harmonic distortion, signal-to-noise ratio, and more. And I'll demonstrate it working in an audio system. Let's begin. So I've set up the system on my bench so we can test some of the features of the preamplifier. Now if you notice on the front panel of the AP1800, it says it's a preamplifier, but it also says it's a control center. So it actually has quite a few extra features that a traditional preamplifier wouldn't have. Now for one, you can actually connect two amplifiers to the outputs of the preamplifier and switch between them. And that's what I've done here. I have a Denon amplifier connected here and a small realistic amplifier connected here. Additionally, the control center allows you to control speakers. And that works by connecting the speaker outputs from one of the amplifiers back into the control center. And in this system, I have the speaker outputs of the Denon amplifier connected to the amplifier inputs of the preamplifier. And connected to the speaker outputs of the preamplifier, I have one set of speakers here and another set here. These old Radio Shack speakers are connected to the A speaker output, and the Sonos Favor speakers are connected to the B speaker output. And the Denon amplifier is connected to output 1, and the realistic amplifier is connected to output 2. And our small Minimus 7 speakers are connected only to the small realistic amplifier. So let's try it all out and make sure the system is functioning correctly. Now the first feature I want to test are the switched AC power outlets on the back of the preamplifier. You may recall from the builds in the previous episodes that the preamplifier has convenience outlets on the back, and this allows a convenient place to plug in the other components. Some of the AC outlets are always live provided that the preamplifier is plugged in, while others are only activated when the power switch of the preamplifier is turned on. And that's a nice feature because it allows you to turn on other components with the flick of just one switch. I have our two amplifiers plugged into the switched outlets in the back of the preamp, so when I turn on the preamplifier, both amps should also turn on. Let's give that a try. There you go. You can see both amplifiers turned on when we turned on our preamplifier, so that's working great. Let's move on to the next test. Now if you look closely, you can see on top I have a Bluetooth receiver here, and I'm streaming some music from the YouTube library to it, and the outputs from the Bluetooth receiver are connected to the auxiliary 1 inputs of the preamplifier. Let's switch to output 1, turn on speaker A, and you can see that the old Radio Shack speakers are playing. Let's switch to speaker set B. And there we had the Sonos Favor speakers playing, so that's working great. Okay, now I'm going to switch to the A+B position, and we should hear sound from not only the old Radio Shack speakers, but also the Sonos Favor speakers. Let's give that a try. Okay, perfect. Now let's switch between them. A, B, and A+B. Okay, so far so good. Now let's try output 2 of the preamplifier, which again is connected to our small Minimus 7 system. Let's switch to output 2. Working great. Now we can also switch the output control to play both systems 1 and 2 at the same time. Let's give that a try. Great, and in that position, all of the amplifiers are playing and all of the speakers. It can also use the outboard amp to drive a set of headphones. Let's give that a try. Sounds great. Let's move on to the next tests. Now let's test the phono inputs. The AP1800 allows up to 3 turntables to be connected at a time, 2 with a moving magnet cartridge and 1 with a moving coil cartridge. Moving coil cartridges are generally considered to provide better performance than moving magnets, but not all preamplifiers can actually work with moving coil cartridges. That's because their output is even lower than that of moving magnet cartridges and requires even more amplification. We're going to test both types of cartridges with our preamplifier, and currently I have a moving magnet cartridge installed in our turntable. Let's fire that up and hear how it sounds. Okay, sounds great. Now let's install this pretty pricey moving coil cartridge on the turntable and let's hear how that sounds. I've got the moving coil cartridge installed on the turntable. Let's select the MC input and hear how it sounds.
The following program is down for the get down production.
That moving coil cartridge sounds absolutely fantastic, and the phono section in our preamplifier seems to be working just great, so let's move on to the next tests. Now let's test the preamp's cartridge sensitivity control. For moving magnet cartridges, you would select the millivolt rating which most closely matched your cartridge. For moving coil cartridges like the one I have installed now, you divide these numbers by 10. So for example, this would be the 0.4 millivolt position. This would be 0.2, and this would be 0.1. The cartridge I'm using has a 0.4 millivolt output, so we'll use this position. Let me turn up the volume now and switch between the positions so you can hear the difference that it makes. So you can see by lowering the millivolt position, the preamp becomes more sensitive, compensating for lower output cartridges. And again, this cartridge is rated for 0.4 millivolts, so this is the correct position. The cartridge capacitance control is used for moving magnet cartridges, and you have three choices to best match the capacitance of the cartridge that you're using. With the moving magnet cartridge I had installed earlier, I detected no difference in sound between the A, B, or C position, but this might come in handy with slightly improving the sound with certain magnetic cartridges. Let's move on now to the next tests. Now let's test the adapter control. This is another handy feature of the preamplifier, and it allows you to use the preamp with an outboard processor, such as an equalizer, without having to use one of the tape monitors. I have this equalizer now connected to the adapter input and output, and when we switch the adapter to the on position, it will put the equalizer in line. You can see that on the equalizer I've dramatically cut the low end and the high end, so when we engage the adapter we should really hear the difference. Let's turn up the volume and give it a try. Working perfectly. Let's move on now to the next test. Let's now test the tape control features of the preamp. I've just used it to record some classical music on this deck and some blues on this one. This deck is attached to tape monitor 1 and this to tape monitor 2. Let's play them back now and switch between them to make sure our tape monitor control is working properly. In tape monitor position 1, we should hear the classical music, and in tape monitor 2, we should hear the blues music. Let's switch between them. Okay, that's working great. Now let's test one more thing about this tape monitor control. You may recall from the build that the switch that was provided was actually 4 positions and not 3. And that gives us a bonus position here before the tape monitor 1 position. To make it work, I just wired it so when it's in that added bonus position, it behaves as though it's in tape monitor 1. Let's switch between the bonus position and the tape 1 position just to make sure that it's working correctly. Works great. Let's move on now to the next tests. Now let's test the preamplifier's mode selector control. I have my audio test software connected to the preamplifier, and in the left channel I'm inputting a 1 kHz tone, and in the right channel a 600 Hz tone. Let me run that and see what it looks like. And you can see here on the spectrum display we have the 1 kHz tone in the left channel, and down here we show the 600 Hz tone in the right channel. I'm going to switch the mode selector to the right channel only, and let's see what we get on the display. And you can see in that right channel position we're getting the right channel input on the output of both channels, that 600 Hz tone. Let's switch now to the left channel mode input. And in this position, we have the right channel 1 kHz tone on the output of both the left and right channels. Let's switch now to the left plus right position, and we should have the inputs of both channels on both outputs. There you go. You can see that the left plus right position is actually just a mono selector, and it puts the input of the left and right into the outputs of both channels. And in the left channel, you can see we have the 600 Hz signal and the 1000 Hz signal. And additionally, in the right channel, we also have the 600 Hz signal plus the 1 kHz signal. Let's now switch to the left minus right position and see what we get. Let's now switch to the reverse position, which will put the left input to the right output and the right input to the left output. Here we go. And now you can see the 600 Hz input from the right channel is now on the left channel, and the 1 kHz tone from the left input is now showing on our right output. Everything seems to be working just great. Let's move on now to the next test. Let's now test the record mode selector. I've already used it in the source position to make those 2 recordings earlier to the cassette decks, and that checks out just fine. Let's now test the 2-to-1 and the 1-to-2 positions. This is another great feature of the preamp that makes recording from deck to deck nice and convenient. In the 2-to-1 position, the playback output of deck 2 is sent to the record input of deck 1. And in the 1-to-2 position, the playback output of deck 1 is sent to the record input of deck 2. To quickly test this, I have a 200 Hz tone going into tape monitor 1 and a 1 kHz tone going to tape monitor 2. When I switch to the 2-to-1 position, our spectrum display should show a 1 kHz tone in the left channel, which is connected to tape 1. In the 1-to-2 position, the display should show a 200 Hz tone in the right channel, which is connected to tape monitor 2. Let's test the 2-to-1 position first. We have our 1 kHz tone in the left channel, indicating that the 2-to-1 position is working. Let's now test the 1-to-2 position. And now we have our 200 Hz tone in the right channel, indicating that the 1-to-2 position is also working correctly. On to the next test. Let's now test the balance control. I'm going to input a pink noise signal to both the left and right channels, and once I get this on the display, I'm going to move the balance control between the left and right positions. Here we go. That's in the left position. Let's switch to the right. Okay, excellent. The balance control is working just right. As I slowly moved it from left to right, you could see the output in the left and right channels increasing and decreasing. Let's move on now to the next test. The AP1800 has some pretty sophisticated tone controls. Let's test those now. Both the bass and treble controls give you a choice between which frequency you want your contour to begin. For the treble control, you can choose a flat response or a contour at 5 kHz or a contour at a lower 2.5 kHz. Additionally, the bass and treble controls allow you to independently adjust the left and right channels. Let's start by testing the 5 kHz turnover position on the treble control. I'm going to input a 5 kHz tone into both the left and right channels, and on the spectrum display you'll see the results as I turn that control up and down. Let's begin. Okay, working perfectly, giving us about 6 decibels of control at exactly 5 kilohertz. Let's try the 2.5 kilohertz control now. And I'm going to switch our tones to 2.5 kilohertz. Okay, let's run the test again. Also working just perfectly, giving us 6 decibels of control at 2.5 kilohertz. Perfect. Let's move on now to the bass controls. We'll test the 250 hertz turnover control first. Let's change our tones to 250 hertz. And let's run our test. Working absolutely perfectly at exactly 250 hertz. We have about 6 decibels of control. Let's move on now to the 500 hertz position. And let's switch our input tones to 500 hertz. Let's run our test. Again, working absolutely perfectly. The tone control section checks out. Let's move on now to the next test. In addition to the full-featured tone controls, our preamplifier also has a full-feature set of filters. These allow us to cut off frequencies in both the bass and treble, handy features for controlling turntable rumble, high-frequency hiss, and for conserving power by not sending the lowest bass frequencies to speakers that can't reproduce those frequencies. Let's give them a try. First, let's test the 20 Hz filter. When this is engaged, it should cut the frequencies from 20 Hz and below. I've got our audio software to output a 20 Hz signal in both the left and the right. Let's run the test now and see how well the filter works. Here we go. Okay, just perfect. You can see at 20 Hz, the filter reduces output by about 3 decibels. Let's try the 50 Hz filter now. Let's change our output tones to 50 Hz. And now let's run the test. Works great, again at 50 Hz, reducing output by 3 decibels. Let's try the high frequency filters now. The first filter is 6 kHz. Let's change our test tones now to 6 kHz. Let's run the test. Great, getting about 3 decibels of attenuation at 6 kHz. Now let's test the 12 kHz filter. Let's hit run to start our test. Okay, good. We're getting a little more than 2 decibels of attenuation at 12 kHz. Now, so far, I've done these tests at the exact frequency of the filter cutoff. But remember, the low frequency filters should cut off all the frequencies below that cutoff frequency, and the high frequency filters should cut off all the frequencies above the cutoff position. Let's just test this now real quick with our 12 kHz filter. Let's change our test tones now to include frequencies at 12 kHz and above. Let's hit run now to begin the test. Great, you can see that the 12 kHz filter is indeed filtering all of the frequencies at 12 kHz and above. The filter section in our AP1800 is working just great. Let's now test the loudness control. I really like how this control works. Unlike the loudness controls found on most audio components, the loudness control on the AP1800 is variable. It's also smartly designed so that the loudness feature can't be abused. Loudness controls really only exist to compensate for the way the human ear hears bass notes at lower volumes. At lower volume levels, the human ear actually has a harder time detecting the lower bass notes. So at lower outputs, you're supposed to engage the loudness control to compensate for this. Unfortunately, these controls are often left engaged regardless of the volume, creating a boomy sound when the volume is turned up. Some people like that boomy effect, but it's actually not considered accurate reproduction. To prevent what I and many consider to be an inappropriate use of the loudness control, the AP1800 provides a brilliant solution. Start with the loudness control in the flat position. Then, instead of using the volume control to reduce volume levels, use the loudness control to actually turn down the volume, which will reduce the mid and high frequencies, but keep the bass notes elevated to compensate for your ear's lowered sensitivity to the bass notes at the lower volumes. In practice, I find this control invaluable, and it's the best implementation of a loudness control that I've ever used. To show the effect of the loudness control on the frequency response, let's input a pink noise signal into the preamplifier and monitor the spectrum analyzer as I reduce the loudness control. Note that as I do so, the mid and high frequencies will be reduced, but the bass notes will stay about the same. Here we go. Works really well. You can see and hear that it reduces the volume but keeps those bass notes elevated. Exactly what you want the loudness control to achieve. Let's now test the muting control. And here, once again, the Heathkit AP1800 is an overachiever, providing not just one level of attenuation for muting, but two. You can attenuate or mute the signal by 20 decibels or 40, your choice. Let's give it a try. I'm going to run the test again with a pink noise signal, and I'll switch between the two muting positions. Here we go. That's -20, and that's -40, working just great. It's now time to test the performance of our preamplifier. Let's start by measuring the signal-to-noise ratio of the high-level inputs. The AP1800 is rated to have a signal-to-noise ratio of 85 decibels. Let's see how it actually performs. Wow, that's truly excellent performance. We're getting a signal-to-noise ratio over 92 decibels, significantly better than even the 85 decibels that the unit is rated for. Well done. The preamp is rated for a frequency response of +0 to -0.2 decibels from 20 Hz to 20 kHz. Let's run a frequency response test with our audio software and see how it's actually performing. Okay, you can see we have an excellent frequency response, very flat, extending below 20 Hz in both the left and right channels and above 20 kHz as well. Again, the response is very flat and very well matched between left and right channels, going to -0.29 and -0.28 at 20 Hz, and +0.53 and +0.55 at 20 kHz. Not quite as good as the +0 to -0.2 rating, but still very good. And I see nothing here to be concerned about given the slight discrepancy between the actual performance and the rated performance. The preamp is rated for a very low 0.02% THD or total harmonic distortion. Let's use our audio test software now to verify this. Note that the test that I'm about to do actually tests THD over the entire audio spectrum and not just at one frequency. And in addition to harmonic distortion, it also includes the noise factor in the results. Let's start the test. Some very good results here and very well matched between left and right. We can see that at the frequency with the highest distortion, around 11 kHz, we're coming in at about or below the 0.02% figure, and for most of the audio band, well below even 0.003%. Very good results. The intermodulation test is similar to a harmonic distortion test. However, in this case, we're looking for the harmonics that are created when two or more tones are mixed together. The test that we're going to do is a fairly standard IMD test. There will be one tone at 60 Hz and another at 7,000. And the amplitude ratio between the two is 4:1. Let's run the test now and see how our preamp compares to the 0.01% rating. Well, there you go. You can see the 60 Hz signal and the 7,000 Hz signal at a 4:1 ratio. And we have a tremendously low amount of intermodulation distortion, barely registering at 0.000792%, way below our 0.01% rating. Again, more fantastic performance from our preamp. Getting the opportunity to build a vintage Heathkit is always special, but building this preamp has been even more so. From the beginning, I was astonished at the quality of both the components Heathkit supplied and the preamp's overall design and features. The preamp worked and tested perfectly at the end of our build, and no troubleshooting or fixes were required. A testament to Heathkit, but also to the build process where we took our time and tested every component before installation. I told you it would pay off. Without a doubt, this is the most full-featured and among the best-sounding preamps I've ever used. There really aren't many modern stereo preamps that can beat it, although a modern preamp will probably include a remote control, which admittedly is handy. That wraps up our Heathkit AP1800 preamplifier series. What will our next project be? Stay tuned. To stay updated, please subscribe to my channel and click the bell to receive notifications when I release new videos. And if you like this video, please give it a thumbs up. I'll see you soon.